Hello everyone, and welcome to our webinar, Leverage the 𝗔𝗵 Scheme, a guide for North American medical device manufacturers. We are broadcasting across North America, and we welcome all attendees from the US, Canada, and other countries as well. This is 𝗔𝗺𝗶𝗱𝗲𝗿. I am a marketing coordinator for 𝗵𝚱 Group Canada, and I'll be your host today. During this webinar, we will explore how North America medical device manufacturers can harness the power of the 𝗔𝗵 scheme to enhance their global market access. Today, our speakers are Leo Einstein, Compliance and Regulatory Consultant, and Holly Rosington, 𝗵𝚱's Energy Commercial Manager. Leo Einstein is the founder of Eisner Safety Consultants and an expert in the standard development process, staying at the forefront of evolving medical device standards for over 20 years, with standards such as IEC 6061 series. He is also an expert member of development teams on IEC 6061-1, edition 3.2, and Fourth Edition of the IEC 6061-1. Holly Rosington is an ISO 9001 lead auditor with 15 years experience in product certification, specializing in electrical products across various market access solution schemes. Her expertise in certification spans from her early career to her current role as Energy Commercial Manager. Please welcome today's speakers. Hi, Holly and Leo.
Good morning.
Hi, nice to hear from you all. Let's talk about our logistics. All participants are muted. We dedicated an hour for this webinar with a separate Q&A section at the end. Any questions that we don't answer will be followed up after the presentation. All participants will receive a link to the webinar recording and a certificate of attendance. A short survey will pop up as soon as the webinar is finished. If you complete this post-event survey, you will receive the presentation slides, the presentation recording, and also 𝗵𝚱's medical device certification market access brochure. Let's start our presentation with a poll. Who's attending today? Please select one answer. Consultant, Quality, Regulatory, or Compliance Officer, R&D, Product Compliance, Design, Development, Engineer, or other. Please use the chat box. I'm gonna give a couple of seconds, and I'm gonna close the poll in 5, 4, 3, 2, 1. And let's see the results. 19% of people are consultants, 54% are quality, regulatory, or compliance officers, 11% are R&D, 14% are product compliance, design or development engineer, and 2% are other. Thank you guys so much for attending. Today, our agenda will be, what is the IEC 6061, the ICE 𝗔𝗵 scheme, the background and timeline for amendments, the IEC 6061-1 changes, and factors that might impact the decision when transition to the amendments. Now, I'm going to pass it over to our first speaker, Holly. You can go, Holly. Thank you.
Thank you so much. So what is IEC 60601? So this series of standards is an international set of standards that pertain to basic safety and essential performance of medical electrical equipment. These standards are issued by the International Electrotechnical Commission, or the IEC, and they're widely used across the world to ensure medical devices are safe for use and they perform reliably. So the 60601 series specifically focuses on medical electrical equipment and systems. These standards cover a wide range of devices used in healthcare settings, including two, but not limited to, medical electrical equipment. So this is equipment such as electrocardiograms or ECGs, ultrasound machines, X-ray machines, infusion pumps, defibrillators, just to name a few. It also includes medical electrical systems. So this is a combination of medical electrical equipment, which may also contain non-medical electrical equipment, which are interconnected. So to bring that to life with an example, we're talking something like a battery-operated patient monitor with its charging dock, or perhaps a CT scanner with its control computer. And lastly, it covers medical software. This category includes software applications and systems used in medical devices, such as patient monitoring devices, diagnostics, software, and electronic medical records. It is important to note that the IEC 60601 series is a matrix series of standards, which contains both collateral and particular standards. The collateral standards are applied to all device types where they are applicable. However, the particular standard are applied only where the device in question is in scope. It is also very possible that a single device can be subjected to the requirements of several standards, depending on its application or intended use. Next slide, please. So I'm just going to give a brief overview of IEC 60601. The specific requirements differ depending on the part of the standard, and it is important to note that the requirements are detailed and comprehensive, but I'm going to cover just a general overview of general categories or requirements covered by IEC 60601. So first up, we do have the general requirements, and this covers topics such as electrical safety, mechanical safety, radiation protection, and general performance requirements. There's EMC, and this specifies general requirements for tests relating to electromagnetic disturbance and emissions of medical equipment. Covers risk management, so this requires manufacturers to follow a risk management process through the life cycle and works in tandem with the risk management process to reduce risk and validate its implemented control. Usability and user interface, this defines a process for manufacturers to analyze, specify, develop, and also evaluate usability in order to mitigate risks from usability issues related to both correct use and use errors. It covers software requirements. So the standard also outlines specific requirements for medical software, encompassing software development processes, software validation, and cybersecurity. Electrical safety, so this can cover aspects such as insulation, earthing, leakage currents, electrical connections, protection against electric shock as well. And lastly, essential performance. So this criteria may vary depending on the specific type of device and its intended use, such as accuracy, measurement range, response time, or alarm functions. Next slide, please. So next, I'm going to give an overview of the IEC CB scheme. So what is it? So IEC is the System of Conformity Assessment for electrotechnical equipment and components. It is a multilateral certification system based on international standards prepared by the International Electrotechnical Commission, or the IEC. The standards and the scheme itself focuses on the safety, performance, quality, and efficiency of electrical products and the components. With the rapid growth of electrical technology in today's world, it is essential to provide assurance to users and consumers that these products are dependable, they meet performance expectations, they ensure safety, and adhere to international standards that align with local regulations. The IEC CB scheme works on the principle of mutual recognition or reciprocal acceptance of test results to obtain certification or approvals at a national level around the world. The intention of the CB scheme is that it reduces the need for additional testing in those countries that the manufacturer wishes to export to, and it also reduces barriers to trade, making access to new markets easier. Different countries have different certification or approval requirements, which means that products would need to be retested to regional requirements for access into those particular markets. So by using international standards and published national differences, it takes away significant delays and cost of conducting multiple tests for different approvals. Next slide, please. So you may be more familiar with OSHA's nationally recognized testing laboratory program, or NRTL or NRTL program. So I want to talk about how the CB scheme can provide market access and actually even support NRTL requirements. The two schemes ultimately have a similar process. They both recognize organizations to perform third-party testing for products to ensure they meet industry standards. In both schemes, the certification body or organization has a defined scope of test standards that they are recognized for. The NRTL program basically sets out to ensure that products are tested and certified for safe use in the workplace. The CB scheme, it ensures safety, quality, and performance of electrical equipment. So the CB scheme benefits several stakeholders. It can benefit governments as it reduces barriers to trade. It can benefit the industry as it reduces the need for repetitive testing. And ultimately, it benefits the end user or consumer that a product has been independently tested. Both NRTL and the CB scheme use a 60601 series of standards. So the AAMI published the US amendments of IEC 60601 parts standards in March 22, and these are now part of the FDA's recognized standard and OSHA's list of test standard. And a similar set of standards was also published by CSA. The NRTL process comprises of two main parts, a factory inspection plus product testing to the standard in that NRTL scope. The NRTL does have ongoing unannounced factory inspections, which are product focused, and they verify procedures are still operating as per the original type test. Whereas the CB scheme is a simple type test with a certificate issued at the end, and there aren't any ongoing requirements. So I'm pleased to announce that BSI have lodged an application with OSHA to become an NRTL for medical devices, which means BSI would be able to support with NRTL, the IEC CB scheme, and notified body approvals like MDR and MDSAP. Next slide, please. So I'm just going to touch on some IEC facts. So the IEC operates globally, qualifying national certification bodies, or NCBs, in each country to recognize and issue CB test reports and certificates. Any country with a full or associate member national committee of the IEC is eligible for IEC membership. So there are 54 member bodies, and these are the representatives of the national electrotechnology communities. There is only one member body per country. The NCBs, there are 94 of those in the scheme at the moment. Operators, then these are the operators of certification or approval schemes for electrotechnical equipment in countries that have a member body of the IECE. There are 566 CBTLs, or certification body test labs, and these are the organizations that perform the testing and issue the test reports against the standards. There are 152 local technical resource across the world, and these are the individuals that operate under the responsibility of the NCB to carry out testing or supervision related activities. And lastly, there are 2,000 listed customer testing facilities, which I will touch on in a few slides' time. And these are owned by the manufacturers, but they can perform their own testing under the supervision of the NCB, CBTL, or local technical resource. Next slide, please. And just to show the size and scale of this, here are some statistics for the growth of certificates during the period that the scheme has been operating. So this comes from the IEC statistics on their website. There are around 120,000 CB test certificates issued every year. In 2023, there were just under 4,000 issued for electrical medical devices, and over 51,000 certificates have been issued in the med category since 2002. Next slide, please. So overall, there are 23 product categories in the IEC CB scheme, but medical products largely fall under two of those categories. So the first is the med category, or medical. So this is the series of standards that comprises over 70 individual 60601 standard or 80601 standards, and they set the safety and essential performance requirements. And the other category is MEAS, or measuring lab equipment. So unlike 60601 series, which has lots of different standards, there is only one, which is 61010-2-101. And this is just a single standard that covers in vitro diagnostics or IVD products. Next slide, please. So how do I get there? The most common route of achieving a CB test report and certificate is with an NCB, or certification body, and their appointed test lab, CBTL. An application for a CB certificate can be made to any NCB, such as BSI. The NCB will then instruct their CBTL to carry out the required testing to an IEC standard or standard within their scope. The CBTL will then go on to issue that test report back to the certification body, who issue the final CB certificate along with the test report. So NCBs can only issue a test certificate for products within their own IEC scope, and you can find a certification body or a test lab's full scope on the IEC website. For a certificate to be recognised as valid within the CB scheme, you need to have both the report and the certificate when making that submission. And lastly, the CB scheme is a one-off certification. So when the standard updates, you should also think about updating your test report and certificate to the latest version. Next slide, please. So I've talked about the most common route to obtain a CB certificate, but I wanted to take a moment to talk about the utilisation of a customer's own testing facilities, known in the CB scheme as CTF. So this is a great option for organisations that have invested in their own lab equipment or research facility and have capability to perform their own testing. The CTF concept involves a thorough qualification of the CTF's capabilities, a confidence building phase, and information exchange between the CTF and the certification body. And this is coupled with a detailed witnessing and supervision program. So as confidence in the quality management system and the experience of the CTF grows, that program of supervision and witnessing changes accordingly, which you can see in the 4 stages on the screen. So the CTF program is a comprehensive process through which personnel from a certification body, a test lab, or even a local technical resource can obtain test data generated at the CTF. The testing facility must adhere to both the technical and quality management system requirements of the CB scheme. So the CTF program ensures a growing level of confidence for the NCB in the capabilities and the experience of the CTF staff, along with corresponding increase in the CTF's responsibility for the test program and its associated activities. The same certificate and test report issuing rules apply as I described in the previous slide, but the report and certificate must contain details of the CTF and the relevant stage. Next slide, please. So what are the benefits of using IEC 60601 and the CB scheme? Well, first of all, there's a whole piece around national differences. So member countries need to publish their national differences, which are available on the IEC website. In countries where national standards are not yet completely based on IEC international standards, declared national differences are considered. So national differences might include the requirement to demonstrate a product complies with factors specific to that country. So let's put that in an example. So Canada publish national differences against IEC 60601-1 to align with Canadian electrical code. So some national differences are more technical and they might set specific limit modifications for leakage current, and some will be really straightforward, such as having instructions in 2 languages. Another benefit is that it reduces or eliminates the need for repeat testing for access into different markets. The CB scheme allows manufacturers to obtain a single certification that is recognised by multiple countries, reducing the need for repetitive testing and another certification process in each target market. Another big benefit is time efficiency. By eliminating the need for multiple redundant tests and certifications, manufacturers can accelerate the time to market for their medical devices. There's harmonisation with local regulations. Many countries align their local regulations with IEC standards used in the CB scheme, and the harmonisation simplifies the process of meeting local regulatory requirements. So really, the IEC CB scheme offers significant advantage for medical device manufacturers, including streamlined market access, cost and time efficiencies, international recognition, and support for innovation. By leveraging the CB scheme, manufacturers can navigate the complex landscape of global regulatory requirements more effectively, ensuring their products meet high standards of safety, performance, while gaining a competitive edge in the global marketplace. Next slide, please. Thank you.
Thank you so much, Holly. That was great. We have another poll now that I'm launching. Is your company or product manufacturer CB scheme certified? Yes, no, I don't know. We plan to be CB scheme certified in the future, or other, please use the chat box. I'm gonna give a couple of seconds and I'm gonna close the poll in 5, 4, 3, 2, 1. And let me share the results. We have 24% yes, 39% no, 24% I don't know, 5% we plan to be on the future, and 8% other. Thank you guys so much for participating again. And now we can continue our presentation. And now it goes to you, Leo. Thank you so much.
Thank you, Yasmin. As a committee member of IEC SC62A, or Subcommittee 62A, and being on several maintenance teams and interpretation working group, which were all part of the development of the IEC 60601 amendments project, and specifically for me, IEC 60601-1, Third Edition Amendment 2. I'll take you on an insider's guided tour of the more significant changes and give you some background during this presentation. Next slide, please. This presentation assumes you know the scope of IEC 601 standard and broadly the requirements as Holly highlighted in some of her slides previously. In brief, the scope applies to basic safety and essential performance of medical electrical equipment and their systems. It's a jumping off point. If you notice at the bottom of the slide, there's a link for a presentation I gave on 15 steps to get approval to IEC 601. So if you need help on understanding some of that, that's a leverage point there. Next slide, please. So what is the amendments project? It consists of the general standard 60601-1 in the upper left-hand corner, the EM disturbances, the 1-2, usability, the 1-6, and all the other collaterals in the rectangular box, plus the diagnostic X-ray standard, the 1-3, just below the rectangle. SC62A is the technical committee in charge of the IEC 60601-1 and the collaterals in the 601 series. And yes, I abbreviate 601 or 60601-1. It's just easier sometimes to say it a little shorter, and has been collecting issues for the amendments project since around 2015, and that have been needing to be updated for reasons including safety gaps, known problems for regulatory bodies, inconsistencies within the standard, the technical nature errors, and updates of key standard references. This is all called the short list, which is the amendments project. SC62A is still collecting current issues for the Fourth Edition project. I'll bring up a few brief comments about the Fourth Edition project throughout this presentation. Next slide, please. Here's the timeline to give you a sense of the scope of the project and timing. SC62A started with 𝗶𝗀 resolution in 2015, the far left dot on the timeline, the road rules. The standards project officially started December 2016, the green dot next to it. SC62A published most of the standards between July to September of 2020, the red dot on the far right where it says publication. Note, the official project took less than 4 years for the amendments to be published, not a full revision of each standard though. Whereas the 601 fourth edition project is a full revision of the general standard and the collaterals. The vice chair of SC62A has set the schedule for the fourth edition project to take 5 to 6 years to finish, but my gut tells me it's going to take a lot longer than that. I call it my retirement plan, and I'm pretty serious about that statement. The fourth edition project officially started March of this year, so very recently, and our kickoff meeting was the end of April in DC. Next slide, please. So as Holly sort of talked about the layout, here's a picture that gives you a little more layout. This is the layout of the current 601 series. So in the upper left-hand corner, you have the general standard, and across the top, you have the collaterals, the -1s. Down the left side are the particulars, or sometimes called the vertical standards. On the right, you have the TRs, the technical reports, the -4s, which are disappearing at this point and mostly turning into technical specifications because of changes in the rules with IEC and ISO. For the fourth edition, the collaterals will actually get compressed into the general standard. So the structure is going to look a little different, to be determined a little bit. Next slide, please. So on the right-hand side, you'll see the publication dates for all the amendment standards, and all of them are there. And the type of changes, which there were 4 different types of changes for the amendments project. Next slide. From the previous slide, you'll notice that all the publication dates were in 2020. And we knew that based on our timing of the project that was going to happen. So the amendments project did not include the particular standards because all the collaterals in the general standard had to get done first before particulars could get done. So the maintenance teams, the working groups, and the joint working groups of the particular standards, we planned through 62D, which is the group that's responsible for the particulars primarily. There's a few standards that are outside of 62D, and I am the US co-chair for 62D. So we met a year or two before, I don't remember the exact timing, and came up with a plan to start in 2021 working on the transition. And we came up with that we should finish by the end of 2023. So we give ourselves 3 years exactly, and said this should get all done by then. But at this point in 2024, we have multiple standards, 2-5, 2-18, 2-25, and a whole list of others that are still not done, partially because there's not enough people out there doing the work. Some of the teams don't exist. And 2-18 is just getting reconstituted after 14 years or something like that. That group just has not been active in a very long time. A recent CB scheme provisional decision sheet was released, how to go about using particular standards that are not updated to IEC 60601 edition 3.2 yet. It is provisional decision sheet 2241 and talks about how to go about the risk management process for this issue that we're talking about right now. So will this impact your transition to the amendments project? If you have a particular, especially one that's not been updated, this will definitely impact you. Next slide, please. As a convention going forward, A1 will mean Amendment 1 and A2 will mean Amendment 2. And you can see on the right-hand side by the rectangles near the bottom, I use A1 and A2. There was a desire to align regulatory requirements to ensure that SC62A updated to the most recent versions of standards that are referenced in the 601 series of standards. Since ISO 14971, third edition, And you can see in the blue, that's the third edition on the right side of the slide, which is the medical device risk management standard has been updated to the 2019 version. All references throughout the general standard and applicable collaterals now reference 14971 third edition or 2019. And if you look just below the blue rectangle, you'll see the reference to the applicable general standard and collaterals. Similarly, you have 62304 edition 1.1 in the green rectangle, and it references just 601-1. If you look to the right, you'll see the red box. The goal was second edition was supposed to be published for 62304, but that project never got completed. Actually, it crashed and burned and never got published. It's just restarting as of the beginning of May is when it got restarted. So it wasn't able to get done under the amendments project. So SC62A had to sort of pivot and just publish under 1.1 for the amendments project. A similar update for 62366-1, the usability standard, edition 1.1 happened, and that's the orange box. And you'll see the orange, blue, and green boxes are also elsewhere in this diagram, showing you how it sort of interrelates with the overall structure of the standards. Next slide, please. So let's get into the changes right away. Next slide. So this isn't a full listing of all the new and updated normative references, but the more important ones. Not all the collaterals are normatively referenced from the general standard, but there is clause 1.3 that talks about how to apply collaterals. The dates of the normative references are critical to be aware of. Note the date of the optocoupler standard on the left side, and later additions are allowed. For the lithium battery standard in the upper right-hand corner is undated, which means the latest edition is required. Both the lithium battery and optocoupler standards referenced here would not meet the requirement of how standards are referenced in the fourth editions project, because you're not allowed to reference an undated version anymore. New IEC and ISO rules. Things keep changing. They never stay the same. Next slide, please. For clause 3, I tell my clients they should read it first so they understand the terms in the standard so they can walk instead of crawl. If you don't understand the actual terms and their definitions of the standard, you'll have a hard time understanding the requirements of the standard. There were over 30 changes to the terms and 2 new terms, which are shown in the next couple slides. At the bottom of this slide is the interpretation sheet 1, which is a very important update that came after the project was completed. Everyone should have a copy of this. It's about essential performance and single fault condition to help explain the process better than in clause 4.3 of the standard. Next slide, please. All terms related to usability in 601-1 were updated. Next slide. The EM disturbance definition has existed in the EM disturbance standard, 4th edition, but the definition was added to 60601-1 as a new definition. That's the first bullet. The rest of the bullets are alarm definitions that come out of Alarm Standard 1-8, which support Table 2, which we'll discuss later in the presentation. Next slide. There were only 2 new definitions added to 601-1, shown here. Next slide. The blue man symbol in A1 was written unclearly, but most test houses required it. A2 made the wording somewhat clearer, but it still is confusing. So the text is being rewritten in Fourth Edition project in Working Group 39. User Interface Aspect Hazards is the short title. I'm one of the co-conveners, as there is a discussion on how this requirement should be implemented clearer and how and when the safety sign should be required. Rewriting the blue man symbol requirement in the Fourth Edition will also address how the I in the booklet symbol will be addressed more clearly. Next slide, please. IP00 was added as a really minor clarification for 7.2.9 for A2. Next slide. In A1, the requirement for switches controlling power to equipment only, to part of the equipment only, was in the wrong part of clause 7.4.2. So it was moved to the more appropriate subclause 7.4.1 and added some clarification, which you'll see in red on the right-hand side. Also, the standby switch symbol, the bottom symbol on the slide, was brought in to bring the device into standby mode. Clarification, really. 7.4.1 is still written sort of messy. So in the Fourth Edition, Working Group 42, which is in charge of electrical hazards, is working to clean up the text, or that's the goal, let's hope. Next slide. So this slide's just to show that the term safety sign is changing from A1 was not defined to A2 is defined. Next slide. So table 2 is a huge improvement from the previous edition. It is much clearer and shows what is expected for cautions, warnings, and alarms. The table was developed by the Alarms Committee, SC62A, Joint Working Group 2, who's in charge of the alarm standard 60601-1-8. The significant change is the 3 alarm rows are totally new, as there was no previous guidance there, and added in clarification for the other colors row at the bottom of the table. There's also lots more info to read and a footnote section at the bottom of the table, which points a lot to the 1-8 standard. It's highly recommended that all manufacturers obtain a copy of the current version of IEC 60601-1-8 to fully understand the alarm requirements. I know, another standard, that's always an issue. Many manufacturers actually should apply it even though they think they only have notifications. If you're using risk management as a mitigation for notification, then you actually have an alarm. Next slide. Maintenance Team 28, Electrical Hazards, made an update to SIPSOPs, or what's known as IO, input-output requirements, in regard to 8.4.2. Before, the standard said to measure the voltage, and if the voltages were above a certain amount, then you need to do a test. Now, the way A2 is written in regards to accessible parts, if the voltage at the SIPSOPs or the power supply output connectors are less than or equal to 60 volts DC or 42.4 V peak, then no touch current test is conducted. And there's a method now in place for how to make the measurement if the voltage is greater than or equal to that amount. You conduct the touch current test. Additionally, you need to test that the energy does not exceed 240 VA or 20 joules at a potential of 2 volts or more. Next slide, please. This figure is helpful as it walks you through means of protections, which is pretty critical in the standard. In A1, it was a figure A.12 informative, which is not a requirement, and was moved to the normative section, figure 40 for A2, and modified the bottom 3 boxes. So the left box dropped the reference to, in quotes, same values as IEC 60601-1, 1988, end quote. 1988 is the second edition of 60601-1. The middle box dropped the reference to, in quotes, IEC 60950-1 simplified, end quote. And I'll talk more about 60950 and 62368 in a couple slides. The right box dropped reference to, in quotes, IEC 60950 apply, end quote, and changed to detailed listing of dated references for 60950, as you'll see there in the red box on the right corner, and added IEC 62368-1 with dated references as well. Next slide, please. And as I promised, I'll talk about 62368 and 60950. So this is information technology equipment primarily. So 60950-1 disappeared because of the EU low voltage directive, and US and Canada replaced it by 62368 third edition as the state-of-the-art standard. This happened midway into the amendments project, and it wasn't planned for, it wasn't expected, let's say. And so it was a speed bump within the project. And so we had to come up with an ad hoc team to deal with this sort of midstream. So it definitely gave us a little bit of a glitch. So the ad hoc team was formed, which I also was part of that team. And we found that 2 means of operator protection at 62368-1 levels were not equivalent to 2 means of operator protection at 60950 levels. And in the previous edition of the standard, 60950, 1 level of means of protection, I mean 2 means of operator protection, excuse me, for 60950 was equivalent to 1 means of patient protection for 60950. But if 2 means of operator protection at 62368 isn't equivalent to 2 means of 62368 wasn't equivalent to 2 means of operator protection of 60950, we had an equivalency problem. So SC62A couldn't generically accept it as an option, and so we had to pivot somehow. So we had to figure out what was going on. Next slide will explain it a little more. So it had a significant impact on major portions of the electrical requirements in Clause 8 and Annex A, the guidance and rationale of the standard. And so it updated the standard much more than we expected because of 62368. Next slide, please. So you'll want to take a look at Note 1 of 8512 related to means of patient protection that are very important pieces of information, which the A2 box in this slide shows the detail of Note 1, just written differently than Note 1 is written. It's a little easier to read probably. If you were looking to take a power supply that's either 62368-1 or 60950-1 evaluated and understand the important voltage measurements that were made across an isolation barrier or a set of barriers, and how that working voltage measurement pertains to 601 and its ability then to serve as a means of patient protection, this is pretty critical. So maintenance team 28 found in a note for 60950 that it provides information that if the working voltage is less than 707 volts DC or 500 volts VRMS as it relates to 60950, then 2 means of operator protection does comply with the 601 tables for 1 means of patient protection, as we stated in the previous edition of the standard. However, if the working voltage across the barrier is greater than that mentioned, you need to look further to see if that's going to work or not. In many cases, it doesn't. And that's what the doesn't equal one means of patient protection error clearance for 60950 is about. And for the 62368 levels down at the lower half of the A2 in that section, you'll see the voltages are much lower. They're about half. So you need to be more aware of what's going on. And for switch mode power supplies, that's a big issue because voltages are pretty high at times. The better option that we recommend to our clients all the time is to use 601 power supplies. And then you avoid this issue altogether. Something also to consider is the ITE type power supplies won't meet the 60601-1-2 EM disturbances requirements that you need to test your overall product. And most likely ITE power supplies are not going to meet those requirements because most of them are not tested to that. Some occasionally are, but not all of them. Next slide, please. So for this requirement for A1, most test labs were already testing to the requirement that didn't exist, but it's written in A2 now. So you have your spacing requirements in the top two bullets, and you have your dielectric requirement in the bottom bullet. Next slide, please. This is a cleanup clause just for your reference. Next slide. This requirement was added to define what is a floating circuit. Next slide. I had a client with this issue as noted in A1. There was no clear requirement and the client dealt with a lab that provided them with failing results. The lab didn't know how to test it because there really wasn't clear requirements for the situation. Finally, the lab agreed it was not being tested properly and we came to a solution, but it was a long, drawn-out battle. It wasn't a top lab either. This all spurred a request for a change, which I submitted for the issue for the 601 standard, but it took many years before the changes occurred through the standards process for the amendments project. Basically, you have one applied part with multiple leads in close proximity inside the body to be treated as one patient connection during these tests. Read closely as there are some provisos in these defibrillation tests. Next slide, please. Detachable power supply cords weren't always consistently tested by test houses, as they didn't always have a 3-meter cord of appropriate cross-sectional area based on A1 requirements in the table 17. With A2, manufacturers have 2 testing options now. Provide power cords for testing. And in reality would mean you provide each version if you have different power cords for various countries, lengths, currents, cross-sectional areas, etc. We recommend manufacturers test each power cord that is being shipped, go through this production line test so you can confirm the power cords are safe to ship. That's we as my consulting firm. The second option is manufacturers specifying the length and cross-sectional area to the test house. Next slide, please. MT28 added back how to deal with internally powered ME equipment, that's battery operated, for leakage current tests. This was taken out when going from 2nd to 3rd editions with standard. MT28 didn't have the bandwidth to add the figures back, so we wrote in words to describe this in A2. Next slide. Table 6, we fixed the typo, that's the rectangle in the table 6. Note 3 is in the bottom right-hand corner was added, and it's specifically for 62368 table 27, and it deals with the voltage issues that we talked about earlier, but different sets of voltages. dealing with one means of patient protection. And I'm not going to get into the detail at this point. You can read the note. Also be aware there's other tables have been updated. There's table 8, multiplication factors for air clearance for altitudes. There's minor standard reference updates. Table 12, there's minimum creepage distances and air clearances providing means of patient protection. Important details all in the notes. Next slide. I've known about this test for about 34 years since I was in the group that tested conductive coating at UL. It is now a requirement in standard finally. The concern is about flaking or peeling of conductive coating doesn't result in shorting of spacings of components or traces on the printed circuit board or elsewhere in the unit. The standards referenced are informative, not normative. They aren't required as they are in the note, which is informative, but you do need a standard to test conductive coating. So it's a good reference to be aware of. Next slide. 11.3a was updated and clarified in A2 from, for example, FV2 to V2, as FV was the wrong reference for flame rating. It should have been V2. Maintenance Team 28 also clarified the types of insulation. Next slide. 11.3b1 was busy and very confusing, so we updated to make it easier to read and understand. Similarly for 11.3b2, but we also added some additional options shown in the bottom 3 bullets of the A2 slide. Next slide. Maintenance Team 30, Overheating, Fire Protection, and Additional Hazards Maintenance Team, updated Table 23. So A1's on the left of the top and A2's on the right. So this is for the normal use condition. That's not part of the title. Just below is the title. And for the title changed from A1 being any equipment parts that are likely to be touched to A2 accessible parts that are likely to be touched. And any equipment, and we changed any equipment to accessible parts in 3 places in the red boxes where you see the blue writing. Also, there is the new table 34, which deals with abnormal use condition at the bottom of the slide. Table 23, as I said, is for normal use when you are intending to touch the product to operate it. Table 34, on the other hand, is for when you are operating the device and touching the product, but not intending to do so. So in a single abnormal situation, less than 1 second scenario of table 23 and also table 34. Look at the temperature limits are higher in table 23 than they're lower in table 23, they're higher in table 34. Because in table 34, it's abnormal use. So for metals and liquids in table 23, they're 74C, and table 34, they're 80. For glass and porcelain, table 23 is 80C, and table 34, it's 90C, etc. Next slide, please. With A2, you still can use IEC 62133, and since undated means to be the latest edition, which is the 2012 version for the lithium batteries. It also added alternative options for the newer standard, the -2 of the lithium batteries. The latest edition means undated. If a regulator or vendor or customer requires a newer standard, being the -2, what's the impact? The implications may include testing for a new CB certificate. Even if someone else pays, you still end up absorbing the cost. Test samples, potential project delays, redesign battery or the battery pack to meet the new requirements. Next slide.
Thank you so much, Leo. I'm gonna launch a new poll for you guys. Are your devices battery powered or battery backed up? Yes, no, I'm not certain, or other, please use the chat box. I'm gonna give a few seconds and I'm closing the poll in 5, 4, 3, 2, 1. And now let me share the results. 57% says yes, 27% say no, and 12% mark other. Thank you guys so much. And now back to you, Leo.
Thank you, Yasmin. So just as a summary, the list that I showed you through the presentation is not an exhaustive list of changes. There are many other changes that exist. So I highlighted some of the more important ones to be aware of. Be alert of other changes when you do your gap assessment, if you haven't done it already. Next slide. So what are the factors that may impact the decision of when to transition to the amendments? The particular standards which I talked about early in the presentation. When will the national standards adopt the amendments? So for the US, AAMI, the National Standards Organization, has adopted the standards IEC, the US versions of IEC 60601-1, 1-2, 1-8, 1-11, and 1-12 around spring of 2021. They won't adopt any of the other standards because those are the ones they deal with. For Europe, CEMLEC has published all the EN general and collateral standards based on the amendments project, and then each European country has to adopt the EN standard, and that should have been done by now based on the date of publication requirement, I think it is. Transition dates of national certifiers such as UL, CSA, BSI, etc. There are lots of other test labs out there that are not national certifiers that you could also look at that might have transition dates. Excuse me. National regulators' transition period timelines. Talk about one. FDA has recognized the amendments as a grouping of general standards and collaterals, pretty much all at once, I believe. But not all the particulars were aligned with the amendments project, so they couldn't recognize them all at once. But they have been, as they've been getting published, they've been recognizing them as much as possible. So there are some that are still not recognized, obviously. Manufacturers' regulatory approvals. This amendments based on when you deal with the transition is going to impact your regulatory approval process. This is the amendments project is a design project. It's going to impact your design timelines. It's going to impact your safety certifications because this is a safety certification issue. It's going to impact new products being ready for market and also potentially legacy products, because there probably are legacy products that are being impacted by the amendments project. So this impacts all your business, your regulatory quality system processes. So you need to look at your strategies and how that all interrelates. And that is, I think, my last slide.
Yes, thank you so much, Leo. I'm gonna launch our last poll for today. Which webinar topics would you be interested in? Please select all the apply. On the road to product compliance, how to get started, batteries, AI as in artificial intelligence, circular economy, or manufacturing devices. I'm gonna close the poll in 5, 4, 3, 2, 1. And let me share the results. Thank you guys all so much for participating. To sum up what Leo and Holly mentioned, 𝗶𝘀𝗺 is a national certification body with many associated CB scheme testing laboratories worldwide, including the US and Canada. We also support medical device manufacturers in obtaining ISO 13485 certification for quality management systems and 𝗺𝗺𝗺𝗵. Through 𝗺𝗺𝗺𝗵, medical device manufacturers need only to be audited once to comply with the standard and regulatory requirements up to 5 different medical device markets. The markets are Australia, Brazil, Canada, Japan, and the United States. If you want to learn more about the IEC CB scheme, please scan the QR code on the screen or visit the website posted over there. And also 𝗵𝘀𝗺 can help you with many different products such as product certification, ISO certification, and gap assessment. If you enjoyed the webinar, please feel free to keep in touch and follow us on social channels. Here's we have 𝗵𝘀𝗺's LinkedIn, Holly, Leo's, and also Leo's website, blog, and how to contact him. Also, if you like this presentation, here are some webinars presented by Leo Eisner on similar topics. Thank you so much for the great presentation, Leo and Holly, and I have a few questions before we finish it up for today. And Holly, how do I find if a standard has published national differences?
Hi, thank you. So yes, you could find the national differences by going onto the IEC website, searching the standard, and once you click on the standard, you will find the national differences there, and if they are published.
Thank you. I have another question. I'm not sure if it's for Leo or you, Holly, but if I want to be CB scheme certified, does it mean that I also have to test and comply to all of my country's 6061-1 deviations or differences?
I can take that one. We may need to get a little bit more information from the person that's asked the question in terms of, their market access requirements. But yes, if there's national differences published and you want to take your product into that particular market, you would need to comply with those national differences.
Thank you. Leo, I have a question for you. What type of components need to be controlled for safety according to EX 6061 series of standards?
Thank you, Yasmin. So any components, I'd say, that impact safety of the device related to such things as electrical shock hazards, mechanical fire hazards, thermal hazards, even radiation hazards potentially. So a great example that we were talking about would be batteries, because they deal with chemical, thermal, shock, and fire hazards are the things that I can think of off the top of my head. Some major groupings of types of components would be mains type or power supply type components. Another would be isolation for safety, such as optocouplers, internal wiring, tubing, sleeving, positioning devices, even flammable components such as printed circuit boards and plastics, and oddball ones like, well, lithium batteries I already talked about, or batteries, labeling material, crimp connectors, other connectors are just a few.
Thank you so much, Leo. And on the interest of time, I thank everybody for attending today's presentation.